All right, guys, Mr. Antonucci here, and in this video, I want to share with you and teach you a little bit about exponential functions. So let's just start off with the basic definition of an exponential function. So a is a positive real number other than 1. Then the function f of x equals a to the x, where a is the base, x is the exponent, is an exponential function with base a. Now, basically, there are two kinds of exponential functions. Exponential growth, which is pictured here, and exponential decay. You can see that as you move from left to right on the x-axis, the y value increases, but it doesn't increase linearly. In other words, in a straight line, it curves upward and gets larger faster the more you move to the right on the x-axis. Similarly, exponential decay has the opposite thing. It decreases from left to right, and as you go from right to left backwards, the graph gets steeper and steeper. As you move from left to right forward, the graph gets flatter and flatter there. So let's talk a little bit about graphing exponential functions. So we looked originally at the graph of y equals 2 to the x just a second ago. One of the things you'll notice is that the y-intercept, when x is 0, of this graph is y equals 2. And the graph has that upward curve type of shape, and it goes through a y-intercept of 2. That is key when graphing another exponential function that has transformations in it. Okay? So let's graph the function y equals -2 to the x minus 1. And I'm actually going to adjust this one a little bit and add 3 outside of the exponent. So there's actually 3 transformations going on here. And remember, when you figure out what the transformations are, here's how you do it. You pretend like you're plugging a number in for x and then simplify it. And whatever operations you do, that's the order you do the transformations. So for example, if you plug a number in for x, first thing you're going to do is subtract 1, and that's going to move it 1 unit horizontally to the right. So if we're looking at this initial y-intercept, it's now going to get shifted over 1 unit. Then after you apply the exponent, the next thing you would do is apply the opposite here, and that's going to flip over the x-axis. So we moved 1 unit right, so this y-intercept becomes this point over here, and then it gets flipped over down to here. Okay? Now, stay with me here. Then after you apply the opposite here, the +3, when you're adding outside of a function, moves it vertically, and this is the direction that you would think. It's going to go 3 units up. Okay? So we're going to go from here up 1, 2, 3. So the y-intercept point is going to be right here. Okay? So now initially the horizontal asymptote of this graph was at y equals 0. If you move the graph 1 unit to the right, it's not going to change it. If you flip it over, it's not going to change it. But if you move it 3 units up, it's going to make the horizontal asymptote 3 units up. Okay, so what we need to do is graph an exponential function that curves to the horizontal asymptote at that red dashed line and goes through that red point. And remember, it flipped over, so it's going to look kind of like this. Okay, and that's how you can graph it using transformations. Now, just to show you, throw it into Desmos right here. The purple graph is the original function. Notice there's that y-intercept point right here. And then the green graph is the transformed function. Remember, it moved, oops, forgot the -1 there. Okay. Now, it moves it 1 unit to the right, flips it over, and then 3 units up. Oh, let's get this right here. Okay, it takes the y-intercept point, moves it 1 unit to the right, flips it over, and then 3 units up from there. Okay? All right, so that's a little bit about graphing exponential functions. Hope that was helpful. You take care.